Hi, how are you all doing today? Well, here's a great problem. A farmer is given 240 meters of fencing. He's to create a farm that's divided into two sections. Okay, what you're going to have to make it simple, we'll call it east-west and north-south fencing. He has to have 3 sets of north-south fencing, 2 sets of east-west fencing, as shown in the diagram. Now, how long should each set of fencing be to maximize the area? So with 240 meters of fencing, how long should these fences be to maximize area? Well, I'm going to solve it in 2 ways. To begin with, let's call the north-south fencing the length y. So we've got y, y, y. The east-west we'll call x, x and x. Why not exactly? Okay, so we're going to solve it more than one way. So we know the whole shape is a rectangle, x times y. So there's a formula for the area, x times y. But what makes it tricky is we've got more than one variable. There's an x and a y. So we have to, what you're going to do is find a way to get rid of a variable, to find a way to link x and y to get rid of one. Well, one formula is that 2x plus 3y equals 240. We know that no matter how we set it out, all the fencing adds up to 240. And I can see there's 2 x's and 3 y's equals 240. Okay, now then, I always treat this equal sign as a balancing scale. There's my balancing scale. Now you know why I went into mathematics and not art. Needless to say, I'm not the world's greatest artist. If you have a balancing scale and each side is equal, if you do the same thing on both, they'll both be equal. If I subtract 1 gram from the left and 1 gram from the right, it will still balance. But if I remove 1 gram here and 2 grams there, it will no longer balance. Same thing with mathematics. I have an equal sign here. So if I subtract the same amount from both sides, the equal sign will still be true. So if I subtract 2x here, I subtract 2x from the other side, it will still balance. And I always say with mathematics, every step has to have 2 rules. Number 1, it must be true and it must be helpful. Well, it is true if I subtract the same amount from each side, and it's helpful because it's isolating y, close to isolating y, because it'll help to substitute in later. Now we have 3y equals 240 minus 2x. Again, an equal sign. What I do to one side, I do to the other. If I divide the left side by 3, I divide the right side by 3. It's true because it's the same on each side and it's isolating y. That's what I'm left with. Y is 80 minus 2/3 x when I've divided every term by 3. So if y is 80 minus 2/3 x, instead of the area being x times y, it's x times 80 minus 2/3 x, because I've just shown that y and this bracket are equal. But the advantage now, we just have one variable, and so it'll be easier to find that maximum value. Well, I'm going to do 2 methods. One's using algebra, and depending where you're studying, and the course outline could be grade 10, grade 11, grade 12, or grade 13 mathematics. And what we have is, if I multiply that x in, we have a quadratic formula with x squared as the highest exponent. I switch these terms around because we used it with the x first. And what I'm going to do is what's called completing the square. I want that x squared on its own. I remove minus 2/3. I take it out of the brackets. If I divide the left by 2/3, I have to do the same thing to the right side. Okay, and dividing by 2/3 like multiplying by minus 3/2. And now we're left with minus 2/3 outside with x squared minus 120x. And I can check myself. Multiply in minus 2/3 x squared minus 2/3 times 120. I can even use a calculator. We'll end up with plus 80x. So that is correct. Now this is what's called completing the square. I add on half this number squared. That's plus 60 squared. But that must equal that. I've just added on minus 2/3 lot of 60 squared. So I've got, that's minus 2/3 lots of 60 squared. So I've got to put plus 2/3 of 60 squared for this equal to still be true. And this is a math pattern, a squared minus 2ab plus b squared. That's why we do it, which is a minus b squared. That's x minus 60 all squared. And this simplifies to 2400. So this is the equation we have. And this front is, if we plot it on a graph that a equals something x, because that's a squared with a minus there, it will be an upside down parabola. This part here is something squared is always positive. With a negative, it's always negative. A negative number maximized is when it equals 0. So this is maximized when x equals 60. Okay, and when x equals 60, for this equation, the left equals 0. So the whole equation is 2400. So the highest point on this parabola is 60. X is 60 and y is, or in this case, a is 2400 and x is 60. All right, so what this is an equation. If x takes on different numbers, an area. If x is 2, what would the area be? Plug in 2, that's the area. If x is 7, what would the area be? Plug in 7, that's the area. So that's areas maximized when x is equal to 60. Well, once we know x is 60, that's our equation relating x and y. We can plug 60 in to solve for y. As usual, we bring that to the other side. 3y, 240 minus 2 times 60 is 120. 3y equals 120, so y equals 40. So there we go. X is 60 and 60, and y is 40, 40, 40. That's to maximize the area. Now I'm going to do it one other method. Now we're going back to that quadratic equation. The other method is using calculus. We do the derivative times that by 2 is minus 4 over 3. X times the constant is just that constant. We set the derivative to 0 to maximize. We know it's maximizing because it's an upside down parabola. And what we do, we can bring this minus 4/3 x to the other side is plus 4/3 x times each side by 3/4. And that's to isolate the x. X equals 60. And then we can go back to substituting to get y, and that's using a different method. And that is how we maximize the area for this farm, given that we've got 240 meters of fencing. We need 3 north-south fences and 2 east-west fences.